When we think of moon landings, we often think of nations, of Apollo, Artemis, NASA, flags, and geopolitics. But 2026 could be the year when this image finally changes. Because while NASA is bringing people near the moon again with Artemis 2, and China is specifically searching for water ice at the South Pole with Chang'e 7, something at least as important is happening. Just more quietly. Private companies are preparing several moon landings at once. Not as a PR stunt or a one-time experiment, but as a business model. This year, that is 2026, 4 landers will land on our moon. My name is Serwan and this is Mars Chronicles. Just a few years ago, every private moon landing was a high-risk experiment. Israel failed with Bereshit. Japan failed with Hakuto-R. Astrobotic failed with Peregrine. Intuitive machines landed but tipped over. The learning curve was brutal. But that's exactly how industry begins. Not with perfection, but with iteration. And 2026 will be a phenomenal year for moon enthusiasts. Several landers will be sent to the moon with different architectures, different business models, and different risk strategies. And that's new. Let's start with the heavyweight Blue Origin. Jeff Bezos' space company was long known for suborbital tourism. Then came New Glenn. And now comes the moon. The company has put suborbital flights on hold for the time being. Blue Moon Mark 1 is not a crewed lander, it's a technology demonstrator, but an extremely important one. Now it gets strategic. Blue Origin is the prime contractor for one of the NASA Human Landing System, or HLS contracts. That means if everything goes according to plan, a Blue Moon lander is supposed to land astronauts on the moon later this decade. Mark 1 is the dress rehearsal. And at the most challenging location, the lunar South Pole. Why the South Pole of all places? Because there are permanently shadowed craters there that contain water ice, and that's where long-term Artemis infrastructure is supposed to be built. If you can land precisely there, you can land anywhere. Here are some technical details. The Blue Moon Mark 1 lander launches on a New Glenn from Cape Canaveral. It weighs a hefty 21 tons and can deliver a total of 3 tons of payload to the surface of the moon. It is a short-term mission. The primary goal here is to test and demonstrate the technology. There is no exact launch date yet, but currently the lander named Endurance is in a NASA vacuum chamber for a total of 11 days to validate all systems. If everything goes according to plan here, we could see the launch in the first half of the year. But of course, that's just speculation. A central instrument on board is NASA's SCALP SS. It's not a classic scientific experiment, but rather a highly interesting technical test. SCALP SS examines how the engine exhaust affects the moon during landing. Why is that important? Because we still don't know exactly how landing dust behaves with larger landers. There is already some experience, but there's definitely still potential here. Apollo spread dust for kilometers. Starship's HLS will be a whole different caliber. That will be really exciting to see. When we start landing regularly, we need to understand how much dust will be stirred up. Does it spread to nearby infrastructure, affect the solar panels, erode the hardware? All of that might sound trivial, but it's not. Blue Origin needs a success. New Glenn already had a successful launch with NASA's Escapade mission to Mars. And they managed to land their booster, but the moon is a whole different league. A precise South Pole landing attempt is a direct demonstration of competence for NASA, Artemis, and international partners. If Mark I fails spectacularly, it will be noticed politically, but it wouldn't be a disgrace on the first attempt. If it lands cleanly, it will fundamentally shift the perception of Blue Origin. That brings us to Firefly, and now things get interesting. Because here we're not talking about a first attempt. Firefly already landed successfully in 2025 with Blue Ghost M1 in Mare Crisium, clean, stable, and not bad. It didn't tip over and there was no fuel leak. That was a signal. Firefly is no longer a startup. They're a functioning lunar supplier. Blue Ghost M2 is the next step and will be more ambitious. It will launch towards the end of the year on a Falcon 9, and the goal is the far side of the moon. The far side of the moon is not directly visible from Earth. That means you need a communications relay. This is where a smart architectural approach matters. Firefly uses its own Elytra orbital transfer vehicle to bring the ESA mission Lunar Pathfinder into lunar orbit. Elytra also functions as a communications relay. That's interesting because it shows that private moon landings are becoming more complex. You can tell that the players are systematically positioning themselves and building up capabilities. Here are some interesting payloads. Blue Ghost M2 is transporting, among other things, Rashid Rover 2 from the United Arab Emirates, a wireless power receiver from Volta Space, and several CLPS science instruments. This is geopolitically relevant because the United Arab Emirates are strategically investing in lunar technology. Europe is providing orbital infrastructure, and the US is providing transport capacity. We are watching as networks are being formed, but why is the far side of the moon important at all? So far, China has been the only country to successfully land on the far side of the moon, Chang'e 4 in 2019 and Chang'e 6 in 2024. If Firefly manages to do that, it will be a massive milestone for commercial providers. And it raises the technological bar. And now the big picture. Up to this point, we see two things. Blue Origin is clearly the heavyweight, conducting a critical HLS dress rehearsal, and Firefly is positioning itself as a reliable lunar supplier with orbital infrastructure. This is more than a game now. It's the start of a supply chain, which was the missing puzzle piece for a long time. Now, two companies are coming that have already been to the moon, but with, let's say, mixed results. Intuitive Machines was the first private company in 2024 to achieve a US moon landing since Apollo. In 2025, IM-2 Athena followed. Another landing, more instability. And now comes IM-3, and that's crucial. IM-3 will once again use the Nova C lander and will launch on a Falcon 9 later this half of the year. From the Kennedy Space Center, it will head to the target region Reiner Gamma. Reiner Gamma is not a typical landing site. That's where the so-called lunar swirl is located. A bright vortex-like structure that is formed due to the local magnetic field. That's extremely fascinating because the moon doesn't have a global magnetic field. But Reiner Gamma shows local magnetic anomalies. IM-3 will have magnetometers and plasma instruments on board to study exactly this region. Because local magnetic fields may protect regolith from weathering by solar wind. That's relevant for infrastructure planning, surface resources, and habitat locations. Intuitive Machines has to prove that they can land stably. Not just landing and hoping, but clean, vertical stability, controlled post-mission, and a repeatable architecture. The NASA CLIPS program is based on the idea we're buying transportation services, not single missions. If IM-3 works smoothly, the Pioneer becomes a provider. If it fails again, it becomes politically more difficult. Now comes a particularly interesting candidate, Astrobotic. Their first lander, Peregrine, launched in 2024 on the maiden flight of the Vulcan Centaur and suffered a fuel problem shortly after launch. It never reached the moon. Now comes Griffin, and this time it's launching on a Falcon Heavy. That alone says a lot. Why a Falcon Heavy? Because Griffin is significantly heavier than typical CLIPS landers. By the way, that stands for Commercial Lunar Payload Services. The goal, the lunar South Pole or the area around it. That means RV requirements, more complex trajectory planning, and an energy-intensive transfer phase. Most of these missions use a so-called low-energy transfer trajectory. That means not going directly to the moon in 3 days, but spending several weeks in cislunar space using complex gravity tricks to save fuel. That saves mass, but that costs time. Griffin is expected to be en route for several weeks. However, this can only be done with unmanned missions, since you want to keep the stay of people in cramped capsules and in the radiation environment of cislunar space as short as possible. Originally, NASA's Viper rover was supposed to fly along. Viper was supposed to search for water ice at the South Pole. The mission was stopped for political reasons, then revived and finally postponed. Now Griffin is carrying Astrolab's Flip rover, which weighs about 450 kilograms. In addition, there's another small cube rover and other commercial and cultural payloads. Flip is particularly interesting. Astrolab is developing rover architectures for future manned Artemis missions. This is groundwork for infrastructure, cargo transport, and construction processes. But 2026 will be different, and here comes the crucial point. 2024 was, can this even work? 2025 was, some can do it. 2026 will be, who can do it again? And who can bring large landers to the moon? So, apart from Blue Origin's Blue Moon, which launches toward the moon on a New Glenn, all the others launch with SpaceX rockets. Firefly and Intuitive machines are flying with the Falcon 9, and Astrobotic is even relying on a Falcon Heavy. That means the private lunar market is heavily dependent on SpaceX's launch capacity. That's no coincidence. Falcon 9 offers high reliability, predictable launch windows, and affordable prices. But in the long run, the question arises, what happens when Starship Orbital becomes operational? Will the moon then be supplied directly on a large scale, or will smaller specialized landers remain more economically viable? Or will several suppliers join forces and book a shared lunar transfer? Share your thoughts in the comments. If you look at all the missions together, a pattern emerges. So we have the South Pole, the far side, and an orbital relay. Magnetic field measurements are being carried out, regolith interactions are being studied, and rovers are being deployed and demonstrated. That's not a coincidence, it's preparation. Preparation for Artemis bases, resource utilization, and permanent presence. And speaking of Artemis, while all these private landers are trying to land on the moon in 2026, NASA will bring astronauts near the moon for the first time since Apollo with Artemis 2. They won't land yet, but will orbit the moon first. The actual landing will then follow with Artemis 3. And for this very occasion, we tried something out here in the studio. We printed an SLS rocket with our Core 1 from Prusa. And I have to say, I'm really impressed by how incredibly clean the model turned out. The details, the structure, even the boosted geometry comes out extremely well. Especially with a rocket like the SLS, you only realize when building the model just how absurdly big and complex this thing actually is. If you do your own printing or want to get started, my affiliate link to Prusa is down in the description, and this is a completely honest question for you. Would you buy such an SLS model in the Mars Chronicles shop? And if yes, what would it be worth to you? Do you want it fully assembled or as a kit to build yourself? Write in the comments how much you would pay for it. I'd be interested. So, and now back to the moon market 2026. 2026 could be the first year when people realize the moon is no longer just a PR destination. It is becoming a logistical space. When you look at all these missions, 2026 at first glance seems like a fireworks display of logos and landers. Blue Origin, Firefly, Intuitive Machines, and Astrobotic. And let's not forget that a demonstration of a Starship lunar mission is still ahead of us. However, it's rather unlikely that this will happen this year. But the probability that it will happen this year isn't zero either. But that's not the real point. The real point is, we're currently experiencing the transition from can this work to can it work regularly, and that's a fundamental difference. Apollo was government run, a monumental institutional sprint. This is different. NASA now purchases transportation services. The CLPS program works like a commercial freight market. You deliver, you get paid. If you fail, it might have been your last mission. Paradoxically though, this approach has led to a healthier culture around mistakes. That's an industrial approach. And that's exactly why setbacks like tipping over, false starts, and valve failures are also part of the process. You give yourself the opportunity to make mistakes during the first attempts. Not as a drama, but as a learning curve. So who has the strongest position? Blue Origin has political backing, but first needs to prove that Mark Wine can land cleanly. Firefly has momentum because they've already delivered successfully. Intuitive Machines is under pressure because almost stable isn't good enough in the long run. Astrobotic has something to prove, but Griffin is much more ambitious. No one is a sure thing. No one has failed. Everyone is still in the race. If we really want to develop a thriving lunar economy, then it also has to be the goal to have different providers. Because by now we know all too well, monopolies are bad in every way. But one thing is often overlooked or underestimated. These missions are not isolated. They are building infrastructure. These are companies that plan to stay. It's true that some will come and go, but the course is set. Relays, satellites, transport vehicles, precision landing systems, dust, interaction data, and rover technologies, these are building blocks. And it's exactly these building blocks that will determine whether Artemis is more than just a prestige program in the long run. If private providers can land reliably and repeatedly, then the moon will become more affordable to reach, visited more often, and economically more interesting. And then the debate shifts from when will we land to what will we build there. Just like the saying goes, build it and they will come. That takes courage, which our players have obviously found. Interestingly, SpaceX is usually just a transport service provider for these missions with the Falcon 9 and the Falcon Heavy. Starship HLS is a different league, but here we see something exciting. While SpaceX is focusing on scaling, other companies are building specialized smaller systems. That's not a contradiction, that's market segmentation. Starship could later deliver bulk cargo. But small dedicated landers still make sense for precise science, flexible missions, and international partners. 2026 will be a stress test. Can several private companies launch, transfer, land, operate, and deliver data in the same year and repeat that? If so, then we're no longer talking about private moon landings, but about a market. We will, of course, stream all these launches here on Mars Chronicles, and the landings as well, of course. Fortunately for us space nerds, most operators these days can no longer afford not to do a live stream. Maybe in 10 years, people will look back at 2026 and say, that was the moment when the moon became private. Not in terms of ownership, but in terms of service, supply chains, competition, and routine. And when routine develops, exploration becomes predictable. And when exploration becomes predictable, infrastructure becomes possible. And when infrastructure becomes possible, that's when true organic expansion begins. Write in the comments who has the best cards and how you think the market will develop. And if you liked the video, feel free to subscribe so you don't miss any more deep dives. And feel free to give the video a like so it reaches more curious people like you and me. My name is Serwan and this was Mars Chronicles. Thanks for tuning in. Per aspera ad astra. Goodbye. Goodbye.